In this lab, we're gonna calculate the number of moles of butane in a lighter. We will have already completed the pre-lab questions from yesterday, so let's take a look at the procedures. We demoed how we're gonna trap the butane gas from the lighter in the eudiometer, and since this can be a little bit tricky to actually do, you're gonna use this group information that is posted around the room. Make sure that you go to the group number that matches the number on your paper. So it should say group whatever, 17 or 6 or whatever. Just make sure that the numbers match before you start your data collection. So you've got the procedures on this side along with the water vapor pressure table. When we look at the data and observations, notice you've got an initial mass of your lighter before you release the butane. You've got a final mass of your lighter after you release the butane. So initial mass, final mass. You have the volume of gas collected in milliliters. So you'll have a graduated cylinder on your paper. You've got temperature in Celsius. So you'll have a thermometer on your paper as well to read the temperature. And then atmospheric pressure is something that we will give to you tomorrow. We might actually put it on these papers as well so that it's on the group data. But that's something that we'll look up tomorrow and have available for you. To find the vapor pressure of water, you're going to use the temperature from number 4 and the vapor pressure table on the left side. So you'll look for the temperature, and then the temperature will tell you what the pressure is in torr. For your calculations, when you calculate the pressure of butane alone, that is going to be similar to what we did in the notes using this equation. So you've got the atmospheric pressure, you've got the water pressure from the table, you're calculating the pressure of the butane. So that would be number 7. Number 8, you're converting the milliliters to liters. Number 9, you're converting Celsius to Kelvin. Number 10, you're going to calculate the number of moles of butane collected with the ideal gas law, which is Pivnert. So that's going to be like this part of the example in our notes. So this is number 7, this is number 10. Then for number 11, to get the amount of grams of butane that were released, you'll do the initial mass minus the final mass. On number 12, you're going to use the number of moles that you calculated in number 10 and convert those grams to moles. Think about what you need to convert grams to moles. On number 13, you're going to use the answer from number 11 as your actual mass and the answer from number 12 as your experimental mass so that you can calculate the percent error. And you've got that formula there to help you with that. And then the rest of these post-lab questions you'll answer on your own. So hopefully that helps, and let us know if you've got any questions.